Hey guys, so we are winding down. We got going to school for a little bit today and get some materials. So my videos will be better. I actually have an answer book for the first time since we left, because when I left I didn't know that I was going to need it. So that'll cut down on some of the work for me in terms of not as much work. So that's a good thing for me. 8-6 is the easiest of the sections, okay? All we really have to do is you graph the points that you're given, and then you determine whether it's linear, quadratic, or exponential. So obviously a linear graph is a line. It would look like this. Okay, so if you graph your points and it looks like that, then we call that linear. Okay, and then if you graph your points and it looks like this, where it starts off really, really slow, but then it really increases like that, that's an example of an exponential graph. Okay, and then the last one is a quadratic, and that should be familiar to you guys. You guys just graphed all kinds of quadratics. Okay, and so your quadratic graphs look like this. So what you have to do, again, for the first part of this section, is you graph the points, you take a look at your graph, and then you tell whether it's linear, exponential, or quadratic. So I'm going to go over some examples. Let me see if I don't know if I want to use the workbook that you see here, or if I'm going to use my textbook. The problem with the textbook is it shows the answers. This one doesn't. All right, so I'll do this. Hold on. Let me move this. Let me pull this in. I don't know if you can see this or not, okay, but these are the problems that I'm going to be working on. Let me see. Yeah, I guess you can kind of see that. I don't know if you can see it on your screen or not. It's really not important that you see the points, but you see how I do it. So I'm doing, in our book, number 11. Again, our assignments will still be sheets because I know some of you guys don't have your books. Okay, so we're doing number 11, okay, and I'm graphing these points. So let me get this out of the way, and I'll pull in some graph paper. Don't forget, you guys have graph paper on your in the files section of the Teams site, okay? So the first point is 0, -3. So I go to 0, -3, and I graph that. 1, 2, 3, I graph that point. And the next one is 1, 0. So I go over 1, 0, and then I go to 2, 9. 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm getting a feel for this one. I don't know about you guys, but I'm kind of getting a feel for what's happening here. Now I have -2, 9, and that's going to kind of give it away. So when I go to -2, 9, that point's up there, and all of a sudden the last one's -1, 0, and then you can kind of see that this one, when I graph my points, is going to be quadratic, okay? So let's look at another example. I'm looking at number 10 now in our book. So this was number 11 in the book. Now I'm doing number 10 in the book, okay? So 10 had 0, and then it was 1/4. So I go up just 1/4. Now your guess is as good as mine. Graphing 1/4, you know, they're not going to ask that you be that accurate. And again, if you don't have if you don't want to print that graph paper because you don't have a printer at home, you can do it on paper like this, okay? You certainly can. Not a problem. And I don't care. When you turn it in, I don't care. I don't care how it is. As long as you guys are turning in your work, this is going to help you immeasurably in Algebra 2. For those of you that are choosing not to do it, now that number has gone way down because I've gotten work from everybody. Some people are doing all their work, some people are doing some of it, some people are doing a little. The people that are doing all of their work in Algebra 2, you're going to be fine. Okay, the people that are choosing to not do it or to do a lousy job for Algebra 2, pray. Okay, I don't know if you're a religious person, but prayer will help you get through Algebra 2, and otherwise, I don't know what to tell you. So you should be doing these problems. I know everyone has access, okay? That has been confirmed because I can tell when you open up the assignment on Teams. So I hope that you're doing it. I hope that you're trying when you do it. You're not just firing some stuff on the paper, because you know, the people that put their time in, you're going to be ahead in Algebra 2. The people who are not putting the time in and are going to struggle, you know, they're going to struggle. Okay, so that's all I can tell you. But let's see. Let's get through this. That's a topic for another day. 0, 1/4, 1, 1. I go over 1 and up 1. And then I have 2, 4. So I go over 2, up 4. 1, 2, 3, 4. I'm starting to get a good feel for what this one's going to be. 3, 16. Uh-oh. 3, and it's off the paper. Okay, so I can tell that this one is going to be exponential. Okay? So for a lot of the assignment, this is what you're going to do. Okay? Probably half of the assignment. Maybe even a little bit more than half of the assignment. And that's what's really important with this part, okay? Now, let me show you the other part that you might, I don't know that you'll see many problems like this. You might only see 1 or 2 problems like this in terms of on the assignment that I gave you. Okay, I've trimmed down the amount of work. I've been impressed with how you guys are working, and since you're working, I'm going to trim down the amount of work. So you'll see when I post it, you just have to do the practice A and the puzzle time for a lot of these. Okay, I took away the warm-up. You guys have been doing a good job. You know, I think for the most part, a lot of you guys have been asking questions, and like I said, some of you guys are really earning respect that will go along, that goes a long way with me. Okay, so now when they give you a chart, okay, so let me pull this way here. And if they give you a chart, I'm going to make an XY chart here, XY. And I'm going to say -3, -2, -1, 0, and 1. And then underneath that, I've got 11, I've got 8, I've got 5, I've got 2, I've got -1. So the first thing that we look at is we look at our top. We look at our x's and see that they're going by the same amount. And in this case, they're going up by 1, okay? So that's going to help us in terms of determining what we have. We're always looking for that to go up by the same amount, and it's helpful if it goes up by 1. Now, underneath this, I'm going to go -3, -3, -3, -3. So what are we doing each time? We're going down 3, and we're going over 1. You might remember that from slope, okay? So when that happens, when you're going up by 1 on the top and you're going down by the same amount on the bottom, this is going to be a linear function, okay? Going up by the same amount, okay? Going up by the same amount, okay? Or in this case, going down by the same amount because we're decreasing. All right, let's look at another example, a different type. I'll go over the 3 different types with you. So this one is going to be -2, -1, 0, 1, and 2. Okay, and then underneath I've got 1, I've got 2, I've got 4, I've got 8, I've got 16. Now we want to see that the same thing is happening to your x's, that you're increasing by the same amount, and we're hoping it's increasing by 1. And that's what's happening here. Increasing by 1. We like that. That helps us. It makes it easier for us. We're in good shape. Now we can identify what's happening on the bottom. How do I get from 1 to 2? Some of you might say, well, add 1. But if I do 2 plus 1, I don't get 4. So what's happening on the bottom? How do I get from 1 to 2, from 2 to 4, from 4 to 8, from 8 to 16? I'm multiplying by 2. So when you go up by the same amount on the top and you're multiplying by a number on the bottom, this is an example of an exponential function. Okay? You look at, this is considered to be our first difference, and here our first difference was the same. You're going up by the same amount, you're going down by the same amount, that's linear. When you're going to get from one to the next and you're multiplying by a number, that's exponential. Here's our last type. X and Y. Okay, so my X and my Y, I've got -2, I've got -1, I've got 0, I've got 1, I've got 2. Okay, so to go up And let's say this is -1, this is -2, this is -1, this is 2, this is 7. So, whew, boy, what's happening here? Well, if I'm looking at my common difference, I can't multiply by a number to get to those. So let's look at this. Let's say here I did -1, and then here I'm doing +1, and then here I'm doing +3, and then here I'm doing +5. Now, you can see that my difference, my common difference, isn't the same. However, if you look at something that's called your second difference, now let's look at the difference of the differences. To get from here to here, it's +2. From here to here, it's +2. From here to here, it's +2. So when your second difference is the same, that makes it quadratic. Okay? So these are the three things that you're looking for in section 8.6. Okay? You are looking for if it's the same on the top, and if you go either add or subtract to get to the next number, it's linear. If you multiply or divide to get to the next one, it's exponential. If it's your second difference that's the same, that's adding or subtracting with your second difference, then that's quadratic. Those are the three types that you'll see when you have the charts. Okay, so that wraps up 8.6. 8.6 was really quick. I don't think you'll have any trouble with that. For the first assignment, for the first week, I gave you 2 assignments. I'm giving you 8.6 and I'm giving you 9.1. 8.6 is going to go quick. 9.1 is going to take a little bit more time. 9.1 is going to refer back to square roots, stuff that you guys learned, probably a while ago. Something I really like to teach, so I'm hoping that when we go through these, it'll make sense to you. Okay? So there is the stuff for 8.6. That finishes up chapter 8 for us. I'm hopeful that that stuff made sense to you. And again, you will see that again. It's not, we're going to see that stuff again in Algebra 2. So hopefully I will have a chance to have some of you guys in my Algebra 2 class, because overall you guys have been a great class to work with. So now we're going to do radicals, okay? And I'm going to break these radicals down into a couple steps. This may be a 2-part video. We'll see how it goes in terms of when we get through these. So this is section 9.1. 9.1 is on properties of radicals, okay? So this is an example of a radical, okay? They call that root. They call it square root. What is the square root of 24? Or they'll say root 24. So in order to find those, the first thing we're going to talk about things that are called perfect squares. I'm going to give you a list of perfect squares. This is not a list that you have to memorize, because you can create this list anytime you want. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared, 36. 7 squared, 49. 64, 81, 100, 121, 144, 169, and 196, 225. Again, you can make that list anytime you want. You don't have to memorize it. Now, for letters or variables, I'm going to start off with x squared. That's a perfect square. Any even power is a perfect square. X squared, x to the 4th, x to the 6th, x to the 8th. I'm going to stop because you guys know what even numbers are. So those are perfect squares. Those are my list of perfect squares. And I'm going to use that list of perfect squares to evaluate things like this. That's not a perfect square. I can't take the square root of 24 and get an integer as an answer. Okay? So because of that, we've got to break that down. I've got to break it down so it's got a perfect square part and what I call a leftover part. Perfect square part, leftover part. So the perfect square part is a perfect square factor that divides evenly into 24. So you look at your list. Now in this case, 1 isn't going to help us with any of these. So I put a little x through 1, even though 1's a perfect square. So what number is on my list that divides evenly into 24? Well, that's 4. And it's 4 times 6. So the way that I simplify this is I look at that and I have my square root of 4, and that's going to equal to 2. So I'm going to make that 2 root 6, and that's my answer. Okay, that's the simplified answer. That's the exact answer. If you were to estimate that, the square root of 24, and estimate it. Now sometimes they do that on MCAS tests. So next year you guys might see this. Estimate that. Well, let's look. Where in my list does 24 happen? 24 comes in here. It is bigger than the square root of 16. It is less than the square root of 25. So it's between the square root of 16 is 4. Root 16 is 4. Root 25 is 5. It's between 4 and 5, so I know it's 4 point something. It's going to be close to 25. I'm going to call that 4.88. I don't know, it's a guess. I'm estimating. So I go to my calculator to check it. And let's see if I can do that on this calculator. Second square root 24, I got 4.898. So that's a pretty good estimate, as long as you're within a couple of tenths. This is not an exact answer, that's just an estimate. This is actually the exact answer. So to give you a couple more examples to look at for those, let's say I had the square root of 50. Well, let's look. What number on my list goes into 50 evenly? And if you look, you'll see the first one that you'll see is 25. So I'm going to make that root 25 root 2. What is the square root of 25? The square root of 25 is 5. So I make that 5 root 2. Okay? So let's say I had another one. Let's say I had the square root of 60. Take a look at that list and see what number will divide evenly into 60. Okay, and the answer to that, the answer that goes evenly into 60 is 4. That's right there. So I make this root 4 root 15. Okay, and the square root of 4 is 2, so I'm going to get 2 root 15. Those are my answers. Okay, so let's look at one that has letters involved as well. So, let me see. What do I want to think of here? Let's do the square root of 20, x to the 4th, y to the 5th. Okay, so in this one we have 3 bases. Okay, we have a number base, and we have 2 letter bases, and we have to treat both of those separately. Okay, so if I look at 20, what's a perfect square factor of 20? Well, that's 4. And 4 times what number will give me 20? And the answer to that is 5. Okay? Now, x to the 4th. Is x to the 4th a perfect square? Yes, it is. And the reason it is because that's a perfect square. So I put that over here. And there's no parts that are left over. Now, for y to the 5th, 5 is not a perfect square. And the reason it's not a perfect square is because it is an odd number. So the biggest even number that goes into 5 would be 4. So I make it y to the 4th times that leftover y. So now I look at the left side and I take the square root of 4. And the square root of 4 is 2. And the square root of x to the 4th is x squared. And the square root of y to the 4th is y squared times root 5y. Okay? So that's how you do one with letters. All right? So now the next thing I've got to do with you guys is I'm going to do some fractions. Okay? So with fractions, you take the square root of the top over the square root of the bottom. Now this one is nice. This one we like, because when I take the square root of the top, the square root of 1 is 1, and the square root of 4 is 2. Because both of those were perfect squares, I didn't have any issues with that. Okay? So let's say I had this. Another one. Why don't you guys pause the video and try that one. Hopefully you paused the video and you made it the square root of 9 over the square root of 16, and the square root of 9 is 3.